everyone. This video is a continuation of normalization process of the last video of this chapter. So, as we are starting with the normalization process, some of the key terminologies are associated with it, and we must first be clear about those concepts so that we can further apply them in the normalization process. So first concept is partial dependency. So partial dependency, what does it mean? So first, in order to understand what is a functional dependency, so functional dependency is something, let's say there are two variables like this, B tends to C, and here the B attribute values can determine the values of the attribute C. That's what the functional dependency is. One of them is a determinant, and one of the other attribute which is to be determined by the determinant is called as dependent. So the partial dependency is also derived from functional dependency, in which the determinant is only part of the primary key. So what does it mean? Let's say, so here you have to assume one candidate key, okay, and then you need to decide the primary key as well. So let's say there is a relation, and in the relation you have AB tends to CD and B tends to C. So here see, in the relation, AB is actually considered as the primary key, and AB, both of them together as a primary key, also determining the values of the attributes C and D, and B alone, a part of the primary key, is determining the attribute C. So as per the definition of partial dependency, that is, the determinant should be a part of the primary key. Here, among AB tends to CD and B tends to C, which one satisfy the criteria of partial dependency? That is your B tends to C, because B is a part of a primary key, and the part of the primary key is able to identify the uh, values associated with the attribute C. So this is our partial dependency. Then the full functional dependence, there is another term called full functional dependence, in which all total the whole primary key is able to determine the all the other attributes in the relation. That is called the full functional dependency. And there is another one dependency called transitivity dependency. So here the attribute is dependent on another attribute, but that is not the part of the primary key. So what does it mean? Let's say X tends to C, X tends to Y and K. X is both determining the values of Y and K, and Y determining only Z, and here X is the primary key. Okay, then the dependency, your K tends to Z, that you need to determine, that becomes your transitive dependency, because X determines the value of Z via K. Okay, so that there should be three different attributes to be able to form a transitive dependency. So in order to apply all these concepts, you must be first clear about the primary key. First determine the primary key, and based on the definition of each dependency, let's say partial dependency, full dependency, or transitive dependency, try to find out which of the functional dependencies in the relation are matching which criteria. That you need to decide. And then after you find out all these dependencies, you can move along with the normalization process. Let's see a table which is in the first normal form. So what does the first normal form say? As per the definition, it should be a table format, no repeating groups, and primary key identified. So here in this table, the primary key has to be determined. Okay, and here the primary key is determined as the combination of project number and the EMP num. And here in it, all the row and column intersection is associated with only one single value. So that is and there is some duplications also. We will take out them or delete them. But before that, we can say that our relation is in the first normal form. So here we have formed our table in an appropriate structure, in a tabular structure or appropriate structure, and we also will try to eliminate the repetition, and then we form the primary key. These are the things that we need to do in the first normal form. Now let's see. So conversion of this table to the first normal form. So first is you need to decide the repeating group. So what is a repeating group? So let's say there are group of entries of same type which exists for a single key attribute occurrence. So that reduces the data redundancies. That is our repeating group. Then there is a three-step procedure for this. So here, let's see the figure, this one. Okay, this figure 6.2. In here, we need to eliminate the repeating groups. So how we will see that? And then what are we supposed to do? We need to identify the primary key. So as I told you, as some of the duplications are to be found in the project num, so we are taking a combination of project num and emp num to as a primary key. Okay, so here the primary key is defined. Now after primary key is defined, you need to find out all the dependencies. So how to find out the dependency? Here in the table, as you have arranged a table with all data, you need to decide which are the functional dependencies to appear here. So which is the determinant, and maybe uniquely, individually, or in a group, they are determining some other attributes. So based on that, just analyze the table and then find out what are the functional dependencies. So here in this table, I determined the project number and EMP number, as both of them has some duplicate in the table. That's why together they are identifying all the records associated with all these rest of the attributes. Now project number is able to identify project name individually. Okay, emp num also, you just have to go to table and look for it. Okay, so emp num alone is also able to identify emp name, job class, and chg hour, charge per hour, and job class can only identify chg hour. So now you are done with all the dependencies. Okay, now dependency diagram. So here it depicts all the dependencies found within given table structure, helps to get an overview. So dependency diagram, actually it's easier for you to know the basic structure of a table. So once you write all these functional dependencies, it's easier to see, maybe uniquely or together multiple attributes are able to identify which other attributes. That makes a picture, that gives a picture to us, and that will help you in the further in the process of the normalization. Let's see once you have all the functional dependencies, the next thing is that, sorry about the sound. So next thing is that you need to make a dependency diagram. So what is the dependency diagram? Just take all the functional dependencies and try to keep on joining all of those. So the first functional dependency is project num and emp num together. The primary keys, they are being highlighted with the dark yellow color, and you need to decide together how they are determining all the other attributes. Then after that, what is the next? Project num. Next is our project name individually is determining the project name. I want to tell you one thing here. After defining all the functional dependency, the next step is to find out the partial, full functional dependency, transitive dependency. Let's not consider full functional dependency. Let's consider only partial and transitive. So as project name is a part of a primary key, so can we say this is satisfying the partial dependency. Yes, correct. Okay, and there is another one, functional dependency, EMP num, determining name, job class, CHG hour. So are they? This is also satisfying partial dependency because EMP num, the determinant, is a part of a primary key. Okay, and another one, the last one. How to solve this? See, the EMP num determining EMP name, job class, CHG hour. Job class determining CHG hour. So we can say EMP num determining CHG hour. So job class tends to CHG hour becomes a transitive dependency. Okay. So in this way, you need to find out which are the dependencies. And there is another one thing I need to mention here, that non-prime attributes. So however, the third functional dependency exists between two non-prime attributes. So, what is a prime and non-prime attribute? So, let's say in a functional dependency, let's say the project num, EMP num, determining all the other rest of the attributes. So here, project num, EMP num, whichever the part of the primary key, those are the prime attributes, and all others are the non-prime. Okay. So if there is functional dependency exists between two non-prime, those are not part of the primary key, non-prime attributes, then we can say that there is a transitivity or transitive dependency. Now, we got a picture of all the functional dependency. Let's look into some of the anomalies. So if you see in the last functional dependencies, looking into the last functional dependencies, let's first consider update anomalies. Let's say if you want to update the job class employee, okay, so for it you need to go to the table in the slide. So if you want to modify the employee analyst Jones, which requires updating many entries, so let me take you to the table here, that will be easier. Yeah, so in the job class, where is that table? Analyst Jones, yes. um, so modifying the job class, that is, let's say application designer for analyst Jones, it requires updating many entries that lead to data inconsistencies. Why? Because if you want to change the job class here, you have to see the employee name, how many times it's occurring here. Again, in this record, this is also appearing. So if you change it here or modify it here, you have to also update in this place also, and that may lead to a problem. Insertion anomaly. So let's say you want to add a new employee to the database or table, so it requires him to be assigned to a given project, and therefore to enter a duplicate project info. So let's say you want to enter your own name here as an employee name, so you have to add a project name also, and that may lead to duplication. So and let's say you are not assigned to any project, but you want to add your name here, then a null value must be entered into the project info, which is again undesired or not valid for a good database. Okay, understood? Now deletion anomaly. Let's say if only one employee, let's say here all of our employees have duplicate data, I cannot take any of the examples. So let's say only one employee is associated with a given project, and if that employee is deleted from the database or table, then the project info will be associated with this, only associated with that employee. So these are three different types of anomalies that may occur in a table. Now let's come to our first normal form. So what does our first normal form say? So all key attributes are defined. We have removed the repeating groups, that is row column intersection have now only one value associated in one block, and all attributes are dependent on primary key. We have determined the primary key, And so all of our relational tables are now satisfying the one or first normal form. But some of the tables, as I explained you, some of the records, not tables, sorry about that, some of the records now still contain the anomalies that I just explained to you. So what are we supposed to do? Now the time is to move on to the second normal form. So the second normal form, what it does actually to make sure that a relation is in second normal form, there are certain rules you have to obey to. But before that, the relation must be in first normal form. Okay, so already we have made sure that our relation is in first normal form, and it has a composite primary key. So what are our primary key? Our primary keys are project num and employee num, if you remember. Now, and if the first NF has a single attribute primary key, then the table is automatically in 2NF. Okay, this is another rule. So first NF to second NF conversion is really simple. How simple? So you need to make new tables to eliminate partial dependencies. So what are our partial dependencies here? Project num tends to project name, and another one here emp num tends to ename, job class, and CHG hour. So as per this rule, we need to eliminate, remove those partial dependency and reassign corresponding dependent attributes. So as per second NF, we need to make sure that it's in first NF that we already have, and now it shouldn't include any partial dependencies. So how to do that? Let's do it here. Now, based on the last picture we had, we have to divide the structure into these three parts. So you have, if you see here, see all the functional dependencies. So you can open the slide in your desktop and try on comparing, keep on comparing. And as you have the partial dependency as project num tends to project name, that is considered as a separate relation. Emp num tends to all these that also have partial dependency, so that goes to a separate relation. And then job class tends to CST hour, that doesn't need to be broken because we don't have to do anything that have a transitive dependency. We are only concerned about partial dependency. Okay, and the rest one goes to the third relation. So all these divided relation must be assigned with a name. This is project, this is employee, and this is a, assignment. See, while you divide, did you already had yeah, no. So did you already had this assign hours? No. So as per the functional dependency, the first one project num tends to project name, you have a determinant and dependent. For the second one, which was making sure that it is a partial dependency, emp num tends to name, job class hour, partial dependency, we broke that. Now job class tends to CHE hour, it still remains here, no need to break it. And the rest one is our project num and emp num tends to all the rest of the attributes. So as all the rest of the attributes have been already included in the other two relation, you don't have to include them again here. We don't need any repetition or duplicate columns in our table. Understood? That's why a temporary attribute can be added here as assign hours. This is possible. It's something you can do. Okay, so let me take you to this one. So in the last figure, 6.4, this one I was talking about. So if the CHG hour changes for a job classification, job class held by many employees, then that change must be made for each of those employees. So if someone forgets to update some of the employee records that are affected by the charge per hour change, then different employees with the same job description will generate different hourly changes. It's all about third normal form. Now, at last, we have these three relations only that we need to take care of to make sure they all of them are in third normal form. Let's move on to our third normal form. So, as per the rule of third normal form, all the relations should be in second normal form, and we have to make sure there shouldn't be any transitivity or transitive dependency. Okay, so to make sure of that, among all these, which one is the transitive dependency? This one. Okay, so let's take it to a different relation. So see, job class CHG hour becomes a new relation as job, and now you have the full all broken relations. Relation is broken into four different relations, and they are all in the third normal form. So third normal form makes sure that a relation is second normal form. There should be no partial dependency and no transitive dependency. Okay, in all the relations.